Today we're going to replace the oil cooler lines on this BMW F10 M5. This is a 2013 model year vehicle, so it's a pre-LCI, and yes, you can see I've got the side gills removed, and there's some other things going on here, project related with this vehicle. But today we're focused on the oil cooler lines, which I have one that's leaking. And while I'm in there, I'm going to replace both of them. Just seems like a logical thing to do. And instead of replacing these with the $300 per oil line parts from BMW, I'm going to take these and have them rebuilt. So the first thing I'm going to do is remove these shields. So the black plastic shield here, and then I believe this is actually a structural stress member. So going to remove these two, and that'll give me access to the lines. They're in a tight space, but it's not impossible to do this job. The tools are minimal, and before you get started, the obvious thing to do is to drain the oil, or you will be bathing in it, so to speak. So get the oil out of the vehicle, remove these two covers, the plastic and the aluminum, and you're off to the races. Back in a moment. Okay, boys and girls, let's move on to the next step in the process here. I've removed the two covers on the underside of the engine. The one in the forwardmost position, that's black plastic, and it's held in place with an array of 8mm fasteners, which are very common to BMW, actually very common to Mercedes-Benz as well. And then the aluminum plate, that's held in place with a number of 16mm fine threaded bolts. So you probably want to use cordless tools just to speed through these removing these fasteners. And I've also, well, first of all, here are the covers removed, laying on the floor at the back of the garage here. And then what I've gone ahead and done is drained the oil from the engine. I've also replaced the drain plug, and I've swapped out the oil filter and replaced it as well. So my advice is to go ahead and take care of that. I mean, you have to drain oil from the engine to do this job, and you might as well go ahead and put everything back in place and get it buttoned up, because you don't want oil dripping at the rear of the engine when you're doing your thing towards the front of the engine with the oil cooler and the oil cooler lines. It's going to be a little bit messy, so just make it easy on yourself and put all this back in place. So let's talk about where the actual problem exists, at least on this set of oil cooler lines. And for me, I have oil seepage right there at those connectors, okay? Actually, the one on the left, it's the one I noticed first, and the one on the right is seeping as well. So what's going on? Well, these lines, the couplers here where the hydraulic line meets the steel part of this line, it's starting to leak. It's not leaking to the degree that it's dripping, but it is causing oil mist back on everything to the aft or behind where these lines are positioned. So there's oil pretty much all over the place. There's oil on the oil pan and on the underside of a number of components, and it's coming from this. A lot of people misdiagnose this as being an oil pan leak when it actually is not. Now, you can see there's just like an oil film all over the place. In fact, there was oil visible. It was a drop or two on the bottom of the oil pan. I instinctively wiped that off with a paper towel earlier, which I shouldn't have done. I should have left that in place to take the video. But anyway, you can see it's pretty glossy, there's just oil film all over the place. And we're going to clean this up. We're going to take care of this. So what is the next step? And that is going to be, we've got an oil cooler line that connects here. We've got another one that connects here. I will probably disconnect this one first because it is the longer run of the two. And I'm just going to basically let this drain. In fact, I'm going to let it drain overnight because it's getting kind of late. And that's just me. But, you know, you do want to be patient with this because you've got a lot of oil in the lines. You've got a lot of oil in the cooler. And, you know, if you're in a rush, it's probably going to be a little bit messy, but if you can take more time doing this job, it's probably to your benefit. Now, what about, and you're probably asking yourself, well, what size bolt is that, or nut rather? It is a 13 millimeter, and I've got I got a wrench right here. So there we go, 13 millimeter. That's all it takes to loosen that. And then what about on the back side of the, or on the side of the engine rather, where do the lines connect? And it's right there. And you can see I already have a socket on the upper bolt, and then the lower bolt is visible. Well, guess what? These are also 13 millimeter, which to my amazement, they're the same. Usually in so many projects, the bolt sizes are different. They vary from, you know, one spot to another, but these are 13 millimeter. And the good news is with the, I'm sorry, getting the light in the way here. These are relatively easy to get to. Once you get this aluminum shield removed, you have good access to that space. So we're going to start in the front. We're going to remove the oil cooler line there on the left side, or yeah, it'll be the left side or driver's side. And then we'll probably do this one, and then we'll probably do the ones on the motor probably last. That's the order I'm going to go in. But we're going to let this drain overnight, and we'll come back to it tomorrow. Okay, it's time for a checkpoint and status on where we are in this project. As you can see, I have both of the oil cooler lines disconnected from the oil cooler itself, and all the oil has drained out of the lines, or at least to the extent that it can. As I roll to this side of the engine here, right next to the oil filter housing, you can see the oil that's dripping. And up top, you can see that green O-ring on the upper oil cooler line, and then I'm going to try to pull this wire shroud back out of the way and see if I can get both the bottom and the top in view at the same time. And there it is. So you can see the green O-ring on the bottom and the green O-ring on the top. Those are the, you know, upper and lower, or lower and upper oil cooler lines. So they are disconnected. And there is also a 10 millimeter, oh, it's up in here. Those lines are secured by there. You can see the hole. I already took that 10 millimeter bolt out, and the lines are basically completely disconnected. They can come out of the vehicle now. That will be, I guess that's my question. Due to the way these are made, they may have to be pulled through towards the rear of the vehicle rather than bringing them forward. I think that's what has to happen because the rigid part of the lines is to the rear, and the, of course, the flexible hydraulic lines is to the front. So we'll see how that goes, and I'll report on that in the next segment of this video. So we did run into a snag, and I think it's important to talk about that. But before I do, these rear lines are difficult to reach. And actually what I suggest is, I mean, you can reach them up, you know, in this space here to a certain degree, but unless you're a contortionist, it's probably not going to be a lot of fun. And the lines, of course, you know, you're working against the tension that is on the green O-rings, so you'll want to wiggle the lines to get them to pull out of the side of the engine here. So what I suggest, I don't have a light handy to get up into this space, but you can actually you can put your hand up in here and go up and over this this brace here, and there's plenty of room for you to go in from that angle and just reach up and over, and it's it worked for me. So that's just a word of advice. If you're going to attempt this, you're probably not going to be able to get your hand into that tight space from the rear, but you can go up and over from this opening between the this brace and the actual steering rack. So, but what did we run into, or what went wrong? And things do go wrong on projects like this. One of the studs on the oil cooler actually snapped. You can see this one on the left. Doesn't look so good, does it? The one on the right, it looks fine. Now, let's talk about this for a minute, because this is very, very aggravating for a number of reasons, okay? First of all, and I need to show this on camera real quickly. Bear with me while I grab this. This is the nut. The nut is steel and the bolt is aluminum. It's actually an aluminum stretch bolt. It's not a stud at all. If you look closely, as I get in close here, and I'll try to add some light, you can see it's not a stud, it's an actual bolt. And that bolt is, well, it was placed into this snout or connector or whatever you want to call it, and it was pressed onto the oil cooler by the manufacturer, but you can't remove it. I mean, it's in this bracket or in this connector in such a way that it won't turn. So, but as you come around the front here, you can see there's just no way to get that out of there. What's even more maddening about this is it's a stretch bolt. Stretch bolts are one-time use bolts. I know this from doing, a number of projects on BMWs, E46s, E90s, E60s, a lot of valve cover gasket projects, those things. So these things they're one-time use. That's why they're aluminum stretch bolts. So what are we going to do, or how are we going to rectify this situation? My plan is to actually use a Dremel tool. I'm going to take the oil cooler off the vehicle first of all. And I'm going to take a Dremel tool and I'm going to slot this front to rear so I can drop the stretch bolt out. I'll get a replacement, and when I put that back in, tension will hold it in place front to rear. There won't be any chance that it will drop out. But if I don't take that approach of trying to repair it, we're looking at an oil cooler that's retailing for around $600, probably $600 to $700, depending on which online vendor you're looking at or your local dealer or whatever type of discount you might be able to muster. But that's what I'm facing, is I need to repair this, the one on the left. And if it goes well, I'll probably just do the same thing to the one on the right, although it's not damaged, because again, it's an aluminum stretch bolt. I don't know if it's just torqued or torqued to yield, but I'm going to figure that out as I I work on this. I'll do a little research, but that is the one snag, and that is a potential $600 exposure if it cannot be repaired. But I am going to repair it one way or another. As far as the lines, I'll determine how they come out of the vehicle, and whether they go, orientation is front to rear or rear to front. How I pull those through and pull those out, I'll get those out tonight, and they'll be in the next video segment. So look forward to that. Okay, the oil cooler lines are now removed, and as I suspected, it is a front to rear operation, meaning you're going to pull the lines from the front to the rear of the vehicle, and then you're going to, before you do that, you'll want to remove that bracket that holds these together. That's the bracket that has the 10mm bolt, securing bolt that I mentioned before. So the lines are conveniently out of the vehicle now, and I have to chuckle because it just wasn't easy. You do have to kind of spin and turn and twist and pull and just be patient. And you can see, well, I don't know how you can see or not, the connectors up in there. You can just barely see them. If not for the paper towel, it's in the way. Let me see if I can get that out of the way. Okay, there you go. So there's the connectors. And as you pull them through, my advice is keep them high. Don't pull them down low here and try to pull against this hose or this wire harness. Just keep them high and keep pulling them back, and everything should work out just fine. But the next step is to get the oil cooler out of the vehicle and do work on the faux studs. They're not really studs, they're aluminum stretch bolts. Get those out of the cooler, get replacements, and do a little Dremel work to make all of that possible. And then at the same time, I'm going to take these lines to a hydraulic shop and have them rebuilt. I think that's the much better option because, again, going through the price structure here, it's $300 per line approximately, retail or online price, however you want to approach it. It's still about a $600 proposition to replace these two if you go with the original lines. And then, as I mentioned, with the oil cooler, that's another $600. So you're looking at $1,200 if if you had to replace the oil cooler and both the lines, and you used all BMW parts. That's what you're looking at before taxes and or shipping. So I hope this helps, and we'll move on to the next step. I'll make some progress and get to the next segment. Okay, the oil cooler is out of the vehicle. Let's take a quick look at the BMW part number. There it is, and you're probably wondering who manufactures this for BMW, and it is manufactured by the Behr Company, B-E-H-R, not to be confused with the Behr Paint Company here in the United States. Rather, this is a subsidiary of Mahle, M-A-H-L-E. That's a German auto parts conglomerate. Also similar name to Meyle, M-E-Y-L-E, one of my favorite OEM parts manufacturers in Germany. So this particular oil cooler is used in multiple vehicles with the S63 TU powertrain, and I'll talk about those real quick. So obviously this one is out of an F10 M5, and you'll also find this exact cooler in the new F90 M5, the F06 6 Series, the F12 and F13 6 Series. That would be your M6 Coupe and M6 Grand Coupe variants, including the LCIs, and I think the convertibles in that mix as well. And then to the current generation, G15 and G16, M8 and M8 Grand Coupes. So BMW likes to use this cooler in all of those vehicles. This is not, however, used in the X models, like the X5 and X6Ms. Those have a slightly different variant of the S63 engine, and I forget the designation for those, but they use a different oil cooler. Now, although all the vehicles I previously mentioned have this oil cooler, the oil cooler lines themselves are different. So, as an example, the F90s, the new F90s have a different oil cooler line set up, but the coolers themselves are the same. So now what are we dealing with here? And I covered this before, but now that we've got it on the bench, it will be easier to look at. I've got a broken stud on this side, and it's not really a stud. Rather, it's an aluminum stretch bolt that has been placed into that casting before it was pressed on to this oil cooler. So you can see here the one that's not broken. It moves, but you just can't get it out. And I've had a lot of, or given a lot of thought to how I would repair this. I even phoned a friend and he fabricated something that would allow this to all go back together very nicely. But I'm really concerned about the stretch bolt situation here. These are one-time use, okay? They should be replaced because they act as a damper or as a spring when they're torqued and torqued properly. So as you would imagine, you have fluctuations in oil pressure. And in fact, I should mention that the oil in the oil cooler is not circulated until I believe it's 212 degrees Fahrenheit, and I forget if that's 100 or 110 Celsius. But you know, the engine has to be at a certain temperature before oil begins flowing through this, and when it does, it's going to be at varying pressures. So this kind of acts as a damper or a spring. And you know, this is not the only application for stretch bolts. You find them in small block Chevys and all kinds of automotive components. Like I mentioned before, I've seen these on valve cover gaskets for a number of BMWs. So I really want to get this out of here. I really want to replace it. I don't want to reuse it. I'm fearful that this could snap or break, and it would be a total mess if it occurred while driving. So I did consider possibly just pulling this connector or snout off of the cooler itself. It's been pressed on in the factory, and I have you know, the tools to do that. I also have the ability to press this back in place. I have a shop press here, but my concern is on the back side that I might actually damage the tank in doing so. So although this is not the most desirable option, I am going to slot this using a Dremel tool, and I won't have to remove all of this. I'll probably start from the rear here at the bottom and work my way up, and then I'll be able to angle this bolt out and insert a new one. And yet everything will still be here in terms of enough meat to you know, allow for tension, for it to be snugged back in and hold all of this together without any loss of you know, clamping force. So that's it. I'm going to move on to the next step, and I hope this helps. I have not seen any videos regarding this oil cooler on YouTube. Time for a moment of reflection and a confession in that I was wrong about something, which we will get into momentarily. Before that, let's take a look at what has been done to the connectors on the oil cooler. You can see they've been slotted from front to rear using a Dremel tool. We'll move over to this side real quick, and same appearance, same program. I am by no means an expert using a Dremel, but these turned out good, or should I say good enough. Back over to the other side, we'll take a look straight ahead or straight on, a profile view, and as you can see, the slots are in a U shape. In doing this, I removed approximately 20 to 25% of the circumference of the bolt hole that was originally there. But again, there are no lateral forces on these bolts, so it's not going to be a problem. I've got a brand new bolt here. Let's insert that, and you can see it drops right in. In terms of movement left to right, it's about the same as it was before, so no change there. And again, the clamping forces are front to back or front to rear, so you know, when there's tension on this bolt, it's not going anywhere. And also, there's enough meat here in this aluminum connector that this is not going to collapse or mushroom or spread apart or, you know, anything crazy like that when this is tightened down. So I'm really happy with this. This turned out perhaps better than expected, and it's going to work out just fine. Now, on to what I mentioned before that I was wrong about. Now, here are the bolts that came out of the oil cooler. They're quite chewed up from making contact with the Dremel tool. As you know, I was cutting the slots out to get these bolts out. They got pretty mangled, but nevertheless, I moaned and groaned about this being, or these being, aluminum stretch bolts. They are not aluminum. They are actually stainless steel. And what threw me on this is normally as a litmus test, I'll grab a magnetic pickup tool and see if there's some reaction, with a nut or a bolt or a washer or something like that to determine at least what it might be in terms of material. And these did not budge, they did not move. A magnet would not pick them up. So what I forgot is that certain grades of stainless steel are not magnetic, or they're not magnetically attracted, so to speak. So these are actually stainless steel. And let's take a look at one of the new bolts here real quick. Hold it up in front of the camera and get it in focus. This is an A270 class bolt, and this is an international standard. We'll look at an old one. Hopefully it focuses. It's the same. It's A270, so it's the same material, the same type of stainless steel. You're probably asking yourself, well, what about the length and all of that? This is a 50 millimeter bolt, whereas the one on the cooler was 46 millimeters. This is the closest one I could come by, which is fine. There's plenty of space. There's no problem there. Plenty of clearance. But the bolt itself is an M8 bolt, and that is a 1.25 pitch thread. So it's an A270 stainless steel. It's 13 millimeter head. It's M8 in threads, and the thread pitch is 1.25. And this one happens to be about 50 millimeters in length. So you can find these at any hardware store, or perhaps you have a Fastenal nearby. They're pretty easy to source, so had no problem getting replacement bolts for this. Now, where did all this go wrong? It really went wrong in that the manufacturer mixed material types here. They have stainless steel bolts, but they have what looks to be like a zinc coated nut and washer combination here. You can see, as I've shown before, this corrosion, this rust. This is what caused the stud itself, or the bolt to snap off. So very unfortunate. Created a problem for me, and it will likely create a problem for others, in that they didn't use a stainless steel nut and washer combo. Very unfortunate, but I'm super pleased with what I've been able to accomplish here as a solution. It's really a no-cost repair, and if I ever get into a situation again where I need to swap out or take off the oil cooler lines, it'll be as easy as pulling these bolts out and installing new ones. So real happy about that. Oh, and here's my trusty Dremel tool, model 395 Type 4. This is a 30-year-old tool, and I'm super happy with it. It's provided outstanding service, but I should probably step into the current century and get a cordless Dremel at some point. But this one's been good to go, so real happy with it. And we'll move on to the next step. The oil cooler lines are currently being repaired at a local hydraulic shop. In the meantime, I would like to reinstall the oil cooler in the vehicle, and the oil cooler is here on the floor. It has been flushed out, cleaned up, cleaned out, and it is good to go. Now, this part of the project was an exception. It was not anticipated. However, I think it's going to turn out for the better, and I'm very anxious to get the vehicle, this project wrapped up, get everything back and reassembled and all of that. So that is something I'm looking forward to. In the meantime, let's talk about the space where the oil cooler is mounted and the mount brackets and all of that. So here's one of the mount brackets, which is being held in place loosely by that center plastic dowel. And as far as this works is the studs on the side of the oil cooler go into these slots where my fingers are, and then the bracket itself is held in place by two Torx bolts, as you see in these positions. So very straightforward, very easy to put this back in place, and it's exactly the same way on the other side. So nothing too difficult. Should be easy to do. Now, one thing I want to mention is this little cap right here with the Torx style slot. This is oftentimes mistaken as the drain plug for the radiator. It is not. It's actually a cover for a vent cap to the AC system. So, just word to the wise, don't pull this out thinking it's the radiator drain plug. It is not. If you pull that cap off and then pull out the vent cap underneath that, you're basically going to have all of the R134A exit the system or exit your vehicle in a very quick manner. So you want to avoid making that mistake. I know others have. The radiator is actually visible right here. It's in this space. And then the condenser for the AC is right here. So although it's obscured and you can't see it, it's in that space. Now you're probably asking yourself, well, where is the drain plug for the radiator? There isn't one. This is one of the newer generation of BMWs that they deleted the drain plug, and as much as I think that was a bad idea, that's what they did. I have done cooling system service on this vehicle. There's actually two cooling systems, one for the engine side and the other for the turbos and the DMEs. I didn't make a video on that. I wish I had, but I will do it again at some point in the future, and I'll come back to it, and I'll do basically a DIY how-to. I will say I did not follow the manufacturer's instructions because I thought they were terrible. I came up with my own way to do a much more thorough flushing of the radiator and both cooling systems, and it worked out really well. So again, I'll come back to that project again at some point. But I'm looking, as I said before, looking forward to getting everything back together and reassembled, and that will be the next step when we get the oil cooler lines back from the hydraulic shop. Looking forward to that very much. Okay, exciting times. We have the oil cooler reinstalled in the vehicle, and we've also got the oil cooler lines themselves back from the hydraulic shop. So we're going to talk about these just for a moment, and hopefully this will help some of you that are doing this job, looking at options, considering what you might do. So as you can see, the new lines are not form fitted the way the other lines were, meaning right here the lines made a hard 90-degree turn in each direction, and then at the fittings going into the cooler they also made a 90-degree turn to the right and to the left here. So I don't think that's going to be a problem. And what this shop has done for me is basically removed the leaking lines, and they've modified the Parker crimp connections. And if you don't know what a Parker crimp connection is, there's actually one right here just for reference. So the hose slips over the pipe, and then the outer circumference of that is actually crimped together, and that's how that was done on the oil cooler lines here. So instead, what the shop has done is they've cut away that outer sleeve, or that crimping section, if you will, and they have replaced those or that piece with Oetiker bands or Oetiker clamps. And if you're not familiar with Oetiker clamps, they are forever. They don't come off, they don't budge. They're very good for rubber hoses, and especially for things that are heat cycled, that incur a lot of vibration and things like that. So they will hold together better than the Parker style fittings. They also have to be literally cut or torn off to remove them. So this is a very, very nice style of fitting, or type of fitting. And if you've ever done CV boots or anything like that, they're somewhat the same. So these are going nowhere, so to speak. I have no concern about them leaking over time. And the hose, just for reference, the hose that was actually manufactured, I don't know who the original manufacturer of this entire hose assembly was, but the hoses themselves were made by Coline, and they were 18 millimeter, made and sourced in Germany, as you would anticipate in that part of the world, and they were very flimsy. I mean, they were formed with the bends and everything in them, but if you exerted any lateral force on them, they would just fold. So very thin-walled, very weak, and I'm actually surprised that they used that type of material. Again, the hose itself was not the problem. It was at the fitting. So the hose was sufficient. And these are low pressure hoses, just so everyone is aware. There's not a lot of pressure on these, so it's not like you have to use some super high pressure hydraulic line, or something braided or anything, or something like that. But that's the update. I can't wait to get these installed, and then I'll work out the routing of the hose. And this is different, right? There are no bends in these, but I'll basically form some bends as I do the install. I get them connected, and the shop did put the rubber isolators back on the hoses for me, so I can adjust those accordingly. But what a project this has been. Again, the oil cooler's in the vehicle, and I can't wait to see all of this back together. On to the next step. The rebuilt oil cooler lines are now installed. Let's take a quick tour of the connection points. Just above the oil filter housing here on the side of the engine block, you can see both of the 13 millimeter nuts that hold those lines in place. They are just a little bit beyond finger tight, and I will get back to tighten those and torque those down properly. Now, moving forward a little bit, the center bolt there that holds the bracket in place, that's where it should be, and it looks good. You can see the Oetiker connections on the new hoses. We'll follow the right one out to the oil cooler, and you can see my modification to the oil cooler is working as expected. That is a stainless steel bolt, washer, and nut. We'll roll over here to the other side and look at that one, and same situation. It's, I believe this is going to work out just fine. And then we'll kind of follow that line out and around. It's hanging down a little bit just from gravity. But, one of the things I was concerned with was whether or not this hose was going to make the necessary radius and bends and, follow in the same path as the factory hoses. And these hoses, I actually put them in a couple of days ago because I wanted them to take on the radius, or I should say, achieve memory of being in this position. As you know, when you take hose off of a spool or anything like that, it maintains that curvature, that bend where it's been coiled up. And this hose, as it's heat cycled, I'll go ahead and put oil back in the vehicle. I'll get the vehicle started. I'll let it get up to operating temperature. I'll probably do that a couple of times, and that will help these hoses to maintain their shape that they're currently in, even more than what I've done so far. Now this hose right here, yeah, I can see it's touching the beam. I'll probably just, for safety's sake, I'll probably wrap another hose around this. Just take like a donor hose and kind of cut a section and make sure that it protects it much the way these factory protectors do. And you have to keep in mind, the motor is moving, the oil cooler does not move, so this is why they are connected via rubber hoses. And you just want to make sure that the hose is not touching anything, because it will rub, and it could be a potential rub, cut, or leak in the future. Personally, I think these are going to way outlast the factory solution or the factory hoses. Again, this is a Continental branded hose, 600 psi, which is way over spec for this application. And I like it that way. I like it to be more than it really needs to be. And then these connections which were redone, I mean, this was originally a Parker connection. If you're not aware that the tubing here underneath this hose, it has burrs on it. So as you slip the hose on, that helps keep the hose in place. And then the Oetiker connection is essentially forever until it's cut off. So this is a much better hose than the factory BMW hose. And that makes me happy. I don't think I'll ever have to touch these again. And that's a good thing. Just one less thing to worry about. So really anxious to get this put back together and to wrap up the project. But let's talk about a couple things here before I wrap up this segment. And you know, just I guess things that we've learned along this journey. Number one, I'm not a metallurgy expert or a metallurgist. You know, I just had to learn a little bit about the difference between aluminum and stainless steel. My fault. I think this modification to the oil cooler I think it's really good. I'm surprised that I was able to recover from that broken stud, and that's all good. And you're probably asking, well, how much did this cost relative to just buying new hoses, or maybe just pitching the oil cooler and buying a new oil cooler? Well, again, you know, the factory hoses are $300 per hose. The oil cooler is $600, so you're looking at $1,200, not counting tax and or shipping, depending on your supplier. And you know, this so far, my out of pocket has been $100 for the rebuilding of the oil cooler lines, and that was really that was probably $90 in labor and $10 in hose and the 4 Oetiker clamps. And then the hardware itself, that stuff is stupid expensive, and I'm saying it's relatively expensive. I think that was maybe $10 to $12 in stainless hardware, and that was really because I couldn't buy individual nuts, bolts, and washers. I had to buy them in like a multi-pack. But so let's just round up and say $115 to modify this, to get this back in operating condition, and that is a heck of a lot less than buying the factory parts. This is a workable solution. This is a good solution. You can see that these hoses have not folded over. They've maintained their radius. They look good. Yeah, this one's touching a little bit. We talked about that. This goes right in place where it should be, and it'll be held in place by the aluminum plate or cover here on the bottom of the engine when I put that back in place. So I think this is going to work out really well. Probably said that one too many times. It will have to be tested, obviously, and I'll do a thorough testing of it. I'll make sure there's no leaks. I'll heat cycle this a couple of times, put it all back together, road test it, etc. But it looks to me like it's going to work out just fantastic. So on to the next step, putting this back together, and we're really getting close to wrapping this up. Apologies for the background cicada noise. We are having the 17-year Brood X cycle, so it's quite loud here today. We also have a thunderstorm moving into the area, so apologies for the background noise. I did replenish the oil in the engine, and be aware you're going to have to add a quart. Instead of 8.5 quarts, you will add 9.5 quarts following the oil cooler and oil line procedure. That said, it would be nice if BMW would have given us the opportunity to have drain plugs or something similar in the oil cooler to get that last quart of oil out of the engine during normal oil changes, but they didn't do that. As far as securing the cooler lines, I went ahead and torqued these down. The TIS information states 18 Newton meters, so just go slow and torque those down properly. They also state that the nuts on the engine block should be 18 Newton meters, but I can tell you the ones from the factory were not that tight. So moving on here, what have we done? Well, I've placed these rubber isolators in their proper orientation. You can see this one protects the hose from the beam, and this one protects the hose from that bracket, and it's really the same thing over here. So I placed those in their proper orientation, and then I've also added a little additional like a donor sleeve, if you will, or a hose that I've cut and sectioned, and that kind of felt like that might be a problem there in the background. And then let's see, getting away from the subject area here, that hose is to protect with this section. This protector is to protect the hose from running in or rubbing against this beam. So again, these are not factory hoses, so I took additional steps to protect those. And if you're, I mentioned before, you're going to have some rubbing even with the factory hoses. If you take a quick look at the cover plate, the aluminum cover plate on the engine, you see that really highly polished area there, or spot. That is from one of the rubber isolators or protectors on the left side cooler line, and over here it occurs for the driver's side as well. So it is going to happen, and you need to make sure that those rubber protectors, the isolators, are again in their proper orientation. So I have allowed the vehicle to run for about 30 minutes in 2 stints, placing a big industrial fan in front of the vehicle, mostly just to evacuate exhaust fumes from the garage. But everything works great. There's no leaks. These hoses are taking their shape quite well, and I'll get everything put back together and buttoned up, and that should work just fine. I did also take some time to clean the underside of the engine. I didn't go crazy, but just using brake parts cleaner and paper towels, I cleaned all of this up, and it was really pretty mucky here on the passenger side of the engine, which is really where the lines, the path that they take. So as you would expect, most of the mess was here, and there was a little bit on the driver's side as well, but not quite as much. So I did some cleanup. Everything's torqued down properly. The hoses have been heat cycled, and I think we're ready to move on and just wrap this project up and call it a success. So it's been an interesting one. Had some interesting twists and turns to this, but for anyone that is watching this video or refers to this video, again, this oil cooler is it's common across all of the newer F90 M5s, the M8s, M8 Grand Coupes, and just pretty much any vehicle with the S63TU powertrain, excluding the X models, X5 and X6Ms. But I hope this helps you. If you have any inquiries or questions, feel free to reach out to me. Thank you.